So problem 1, we want to solve the linear equation. So we're going to start by distributing that 5 and that 2 across to get rid of all those parentheses. So I'll end up with 5x minus 20 minus 2 is equal to 2x plus 14 minus 3. And so I get 5x minus 22 is equal to 2x minus 11. And then I can subtract the 2x over and add the 22. And I'll get 5x minus 2x is 3x on the left-hand side. And on the right-hand side, I'll have negative 11 plus 22. Oh, that's a positive 11. Positive 11 plus 22 is 33. So then I'll get x is equal to, if I divide both sides by 3, I'll get x is 11. On the next problem, I see all these denominators, the 5, the 4, and the 2, and so what I'm going to do is I'm going to multiply the whole thing through by the least common multiple. And so the least common multiple of 5, 4, and 2 is going to be 20, and so I'm going to multiply the whole thing through by 20. And so I'm going to have to do that to each part. And so when I do that, I'll have 20 times x minus 1 over 5 plus 20x over 4 is equal to 20 times x plus 3 over 2 plus 20. And now I can reduce things. So 20 divided by 5 is 4. Plus 20 divided by 4 is 5x. 20 divided by 2 is 10. And plus 20. And then I can distribute these things in. And so I'm going to have 4x minus 4 plus 5x equals 10x plus 30 plus 20. So I get 10x plus 50 on the right-hand side, and on the left-hand side I'll get 9x minus 4. And then I can just subtract the 10x over and add the 4. And I will get negative x is equal to 50 plus 4 is 54. So I get x is equal to negative 54 on number 2. On number 3, it says identify the following equations as conditional, identity, or contradiction. So what is meant by this? So conditional means it's only true for some x. In this case, since they're linear, it would just be true for one value of x. Identity means it's true for all values of x. So it's always true, no matter what x is. And contradiction means it's not true. So what happens here? So for this conditional one, when we solve it down, we'll end up getting x equals some number. If it's true for all x, if we solve it down and reduce both sides and everything, we should get something like 0 equals 0, or 5 equals 5, or something like that. If we see that, something like that that's a true statement, then that will be true for all x. That'll be an identity. If it's not true, we might get something like 0 equals 7, or some untrue statement once we solve it down. So let's see what we get here. So let's start with the first one. I'll make some space over here. So the first one, we have negative 5 plus 3x is equal to, I'm going to go ahead and distribute that 3x minus 3 minus 2. And so I get negative 5 plus 3x is equal to 3x minus 5. I can see that that's true. That's a true statement for all x. So A is an identity. Okay, and on part B, I can see that I have 2x plus 12 is equal to x plus 4. Okay, I can subtract the x over and subtract the 12 over, and I will get x is equal to 4 minus 12 is negative 8. So that's true for that only one value of x. So this is conditional. because I got something like x is equal to some number. The next one I can look at. And I can distribute this in. I get 6x minus 1. Oh, 6x minus 3, excuse me. Is equal to 5x minus 4. And I can subtract the 5x over and add the 3. And I'll get x is equal to negative 4 plus 3, which is negative 1. So this is conditional. And the very last one, I can distribute that negative 2 in there. I'll get 6x plus 13 is equal to, so negative 2 times 4 is negative 8. Negative 2 times negative 3 is going to be plus 6x. So I can subtract 6x from both sides, and I'll get 13 is equal to negative 8. And we can see again that's not true. And so this is a contradiction. It's not true for any x's. Okay. Okay, so for the next problem, we will look at this. I'm going to solve this rational equation. So what I'm going to do is I'm going to use a strategy similar to what I used in number 2. I'm going to multiply by the least common multiple. And so if I look at this x squared minus 4, I can see that I can write that in factored form. And x squared minus 4 factors to x plus 2, x minus 2. And this one is 1 over x plus 2. And so what I can do is I can multiply by the least common multiple. So if I multiply by x plus 2, the whole thing by x plus 2, then that is going to get rid of this denominator and part of that denominator. I'm also going to multiply through by x minus 2 to get rid of the whole denominator. So I'm going to multiply through by x plus 2, x minus 2. I'm going to do that for each term. When I multiply 0 by x plus 2, x minus 2, that just makes 0. And so what I'm going to see here is I'm going to see this x plus 2 and that x plus 2 are going to make 1. That's going to make 1. That x plus 2 and that x plus 2 are going to make 1. And so what am I left with? For this term, I'm just left with the 5 minus, and then I have 1 times x minus 2. And that's equal to 0. So I'm going to have 5 minus x plus 2 equals 0. So I can add that x over. I get x equals 7. On this one, I want to solve E equals IR for R. So if I start with E equals IR, what operation is going on between the I and the R? Well, they're being multiplied together. They're sitting next to each other like that, and that is implying multiplication. So if I want to undo multiplication by I need to do that by dividing both sides by I. And then I can see that R is equal to E divided by I. And so I have solved for R. All right, the next one says I want to tile a rectangular kitchen that is 4 feet longer than it is wide. And I also know that the perimeter of the kitchen is 48 feet. So I think the first thing that you would want to do here is draw a picture. So if we draw a picture of this rectangular kitchen, I can see that I'll just call this the width and this the length. And I know that the length is equal to the width plus 4. So that's one thing I do know. And then I know that the perimeter of the kitchen is 48 feet. Well, what does perimeter mean? That's the distance all the way around. So I'll have 2 widths and 2 lengths that I'm adding up to make 48. So 2W plus 2L is equal to 48. And I can go ahead and substitute this W plus 4 in for this L, because I know W plus 4 is equal to L. So if I do that substitution, I'll get 2W plus 2 times W plus 4 is equal to 48. So that gives me 2W plus 2W plus 8 equals 48. I can solve that for W. I'm going to get 4W equals 40. Divide by W, I get W equals 10, which means that the length is 4 more than that, so the length is 14. And so what that means is that the width is 10 and the length is 14. Those are the dimensions of the kitchen. That's the answer to part A. On part B, it says how many square feet of tile should be ordered if the contractor adds an additional 10% to account for waste. And so here, I need to find the area of this kitchen. I know that the area of a rectangle is length times width. So the area is going to be 14 times 10, which is 140 square feet. And then what I want to do is I want to add an additional 10% of that 140 square feet. So to find the additional tile, I want to find 10% of 140. So I'll multiply 140 by 0.10 to get 10%, and that's 14. So that's the extra tile. So if I want to add that extra tile to the tile that I was ordering, I will have 154 square feet of tile. So I have the 140 to tile my kitchen plus the extra 10%, which is 14. Add that up, I get 154. Okay, so the next one says Laura is borrowing money, and she's borrowing a total of $22,000 from 2 different banks to start a business. So we have bank, so let's let A be the amount borrowed at, 4%. And let's let B be the amount borrowed at 5.5%. Simple interest. And so I know that I'm given that the total of those two things should be $22,000. So A plus B is equal to $22,000. The other thing I know is that the total interest after 1 year was $910. So how do I compute the interest? So what I want to do is the interest from the 4% bank plus the interest from the 5.5% bank should total up to $910. So how do I compute this interest here from this 4% bank? Well, what I want to do for that is it's going to be the amount that I borrowed, which is A, times that's 4%. So 0.04. And then how do I figure this part? Amount borrowed from that bank. So I can do the amount borrowed from that bank, which is, I've called that B. And then I'm going to multiply that by 5.5%, so 0.055. And when I total that up, that should be equal to 910. So I get another equation that deals with A and B. So what I'm going to do is I'm going to use these two equations, this one and this one, to solve. So I can see that that B is equal to 22,000 minus A. So I'm going to substitute that in here for B. So 0.04A plus 0.055 times B, which is 22,000 minus A, is equal to 910. And so I just want to solve for A. So I'll get 0.04A plus, and I'm going to distribute this into both of those. And so 0.055 times 22,000 is 1,210 minus 0.055A is equal to 910. And so then I want to combine like terms. So negative 0.055 plus 0.4 is going to be, negative 0.055 plus 0.04, there we go, is negative 0.015. And if I subtract the 1,210, 910 minus 1,210, I get negative 300. Oh, sorry, there's an A there. And then I can divide. And I get that A is equal to 20,000, which means that B is 2,000. So those are my amounts borrowed at the different accounts. So the A was the amount borrowed at 4%, and the B was the amount borrowed at 5.5%. So the next problem says a motorist drives on State Road 412 to and from work each day and pays $2.75 in tolls one way. Write a model for the cost of tolls C of X for X working days. So if we think about this $2.75, that is one direction. So what does that mean? That means each day they're paying two of those because they have to go to work and also come home from work. So C of X is going to be equal to the amount they pay in tolls, which is $2.75 times 2. And then we want to also multiply that by the number of days, which is X. So 2 times 2.75 is $5.05. $5.50. So C is equal to 5.5x. Okay. The second one says how many liters of a 20% alcohol solution should be added to 40 liters of 50% alcohol solution to make a 30% alcohol solution. So I think something that's helpful on these is to draw a picture. So I have some 20% alcohol solution. So I'm just going to draw a container here with 20% alcohol. So 20% alcohol. And I don't know how many liters of that there are. I'm just going to call that X. Okay. And then I want to add that to 40 liters of a 50% alcohol solution. So 40 liters. And this is 50%, so I'll draw it up here. 50% should be equal to... Now, when I add those up, I'm also adding the volumes, right? So how much volume is in this one? If I add X liters plus 40 liters, I'll have 40 plus X liters of this one. And then I want that to be a 30% alcohol solution, so we'll put it right here, 30%. So how much alcohol is in each of these? So if this is 20% of X, that's 0.2X alcohol. This is the amount of alcohol. And then 50% of 40, that's 20 liters of alcohol. So that's 0.5 times 40, which is 20 liters of alcohol there. And then how much alcohol is here? Well, it's going to be the 30%, so 0.3 times 40 plus X. And so now I have an equation here that I can solve for X. So I'll have 0.2X plus 20 is equal to, and I can distribute that 0.3 into both of those, and I will get 0.3 times 40, which is 12, plus 0.3x. Okay, and then I can subtract the 12 over, subtract the 0.2x over, and I'll get 20 minus 12 is 8, is equal to 0.1x, and I can divide by 0.1, and I get x is equal to 80. So what does that mean? That's 80 liters of this solution is what I need to add to 40 liters of that solution to make a solution that is 30% alcohol. So that's the answer to number 9. On number 10, I have 2 passengers leaving the airport at Denver, Colorado. One of them is taking a 2.3-hour flight to Seattle. The other is taking a 3.3-hour flight to New York City. Then it says the plane flying to New York is flying faster, 60 miles per hour faster than the plane flying to Seattle. And then it tells me the total distance traveled by both planes is 2,662 miles. Then I want to find the average speed of each plane. Okay, so let's think about the things that I know and the things that I don't know. So the thing I'm trying to determine in the end is the average speed of each plane. So let's say, let's give some variable names to this. So let's see, I've got Seattle and New York. So let's say S is the average speed of the plane flying to Seattle. And I'm going to say N is the average speed of the plane flying to New York. Okay, and so that's one thing. The other thing I might notice is I have things about time. I have time periods. I have some things about speed, and then I also have some distance. And so what are we going to use here? Is there any equation that relates time and distance and speed or rate? So I know that distance is equal to rate times time. And so that is what I'm going to be using here. So I know my total distance is going to be the distance that the Seattle plane traveled plus the distance that the Denver plane traveled. And so let's go over here and we'll make an equation. So the total distance is going to be equal to the distance that the Seattle plane traveled plus the distance that the, where was it going? New York plane traveled. And if we add up those two distances, we should get 2,662. Agreed? Okay. So the distance that the Seattle plane traveled. Well, I know the distance is rate times time. And so my Seattle plane is traveling at a rate of what? S is the rate of that Seattle plane. And it's traveling for how long? So the Seattle plane is traveling for 2.3 hours. So we'll say S times 2.3. And then what about the New York plane? Well, the speed of the New York plane I've called N, and it's traveling for 3.3 hours. And so that's going to be 3.3 N if I do the rate times time. And that's going to need to be equal to 2,662. All right, so there's one other piece of information I haven't used yet, and that was this, that the plane flying to New York flies 60 miles per hour faster than the plane flying to Seattle. So I can do this relationship here between N and S and using that 60. So if I take the speed of the Seattle plane and I add 60 to it, that should be equal to the speed of the New York plane. So S plus 60 equals N. And so I can replace the N with this S plus 60. So that's what I'm going to do over here. So I'm going to say 2.3S plus 3.3 times S plus 60 is equal to 2,662. And so if I distribute that in to both of those, I get 2.3S plus 3.3S plus 60 times 3.3, which is what? 60 times 3.3 is 198. And that's 2,662. Okay, so I can subtract the 198. 198. And I get 2,464. And then if I add the 2.3 plus 3.3, I get 5.6S. And then I can divide that by 5.6. So 2,464 divided by 5.6. And I get S equals 440. And what are the units of that? Well, what was S? S was the average speed of the plane. So I think that's going to be in miles per hour. And then I know that the plane flying to New York flew 60 miles per hour faster. So I can add 60 to that. And I get 500 for the speed of the plane going to New York.